it's called a comprehensive tutorial. We have 3 hours. Comprehensive might have been just a smidge of a lie. We're going to cover as much as we can over the next 3 hours. For those of you who don't know, I do a lot with large language models. I post a lot on LinkedIn. If you ever have any questions, friend me on LinkedIn, ask me questions. I probably have thought about it at some point. I have like 3 different newsletters that I'm running now because I just go have interesting questions and then feel the need to go share those because then I forget them immediately. Today, we're going to talk about large language models. We're going to talk a little bit about how they work in the background. We're going to keep it about high school level for how they work in the background. Everyone's going to be able to understand that part. We're going to talk a little bit about data management, some of the ethical concerns. I know that there's AI bias. We're also going to be talking about some of the LLM bias that's introduced. We're going to do lots of group activities. I firmly believe that we should all get our hands in there and be talking amongst ourselves. Oh goodness, we're going to talk a little bit about future trends, things that we're seeing. And so just for some quick shows of hands, I'd like to have some sense of who I'm talking to in the room. If you are here hoping that I'm going to talk about the latest and the greatest research, this is not that presentation, this is not that workshop. This is going to be more of a hands-on. I want you logging into LLMs and using them and working with your group and talking. If everyone in the room is an expert and already knows all the latest research, I'd love to chit-chat with you about it, and I'm more than happy. But if anyone thinks and identifies themselves as more of a beginner, hey, I go use the prompts, everyone uses the prompts, but I don't really know how to optimize, I don't know what I'm doing necessarily, if you could just raise your hand. Okay. What about, the more intermediate, hey, I write prompts. So my definition of whether a prompt has been prompt engineered or not is it's at least 500 words. Is every prompt that you're building around 500 words before you say, I give up, it's not enough prompt engineering? If that's so, you're an intermediate. Do we have any intermediates in the room? Yes, okay. And how many people would consider themselves advanced? They read all their academic papers that come out, and they probably can get everything that there is to get out from large language models. Awesome. You're not going to help, right? Excellent. So, this is just another way of talking through. We're going to start with the foundations of large language models, talk a little bit about data and ethics, how do we deal with practical applications, future trends, and then we'll do some collaborative hands-on projects. If you do not have an account with a large language model, I don't do my own thinking anymore. I highly recommend. Here are some providers who have free versions of large language models for you all. I know, I'm sorry. I'm a yeller, so if anyone can't hear, just start waving your hands. If you have any questions during the entire workshop, shout out, because everyone else probably has questions as well. I'm going to recommend this GROQ if you don't have any accounts at all, because it's instantaneous. You run a prompt and it returns 1,000 tokens a second. If you want a programmer, Claude is pretty fantastic. It's a free version. Gemini is okay. I have a few use cases for Gemini. DeepSeek's amazing, but it's from China, and maybe if you're using a work machine, they're going to have a few concerns over using DeepSeek. I don't know. I'm not your employer. But I would recommend signing up for one of these if you don't have some access to some type of LLM already.
What concerns does someone have over using DeepSeek?
So, I use DeepSeek extensively because I don't have any proprietary information. The question was asked, what concerns would someone have over using DeepSeek? So DeepSeek is hosted and built in China. Most employers are going to have concerns with using DeepSeek for 3 reasons. One, if it's just your employer data, most likely the Chinese government does have access to any of the data going through DeepSeek. Admittedly, they probably have access to everything else in my life. I'm not truly concerned about it. Healthcare data. If you use DeepSeek with any type of healthcare data and it's going offshores, there are major concerns when you use any server where your healthcare data is not staying within the egress of the United States, because legally you start having different countries' laws apply to the healthcare data. And so every large healthcare employer is going to say only use a server on the continental United States. Well, I don't know, this is a little strong. Within the egress of the United States. Unless they have specifically carved out some, Cleveland Clinic has methods and means where they're partnering with Israel and have very strong instances in Israel for their Epic instance. I haven't talked to them lately. I believe that they spun up a completely separate Epic instance so that it would have clear boundaries between which country had egress over the healthcare data at the time. But that's the big reasons. Frankly, DeepSeek is one of the best free options out there and has been causing problems for the American market. If you can go ahead and open up the GitHub. I'm somewhat assuming that you've brought a computer of some sort. I have example files and I did not print things out. I did do my best to have it up on the slides as well, but it will save you time if you have access and you can just download things. So while we're getting that,
You may want to remind everyone of the password.
here's the password.
The Wi-Fi.
Oh, the password for the Wi-Fi? IS25 was the password for the Wi-Fi. Which I can't believe I remember that. I just signed into it about 30 seconds ago. So while we're waiting for that to come up, let me tell you a little bit about myself. I spent the last year writing large language models in healthcare for Taylor and Francis, the publisher. It's not published yet. I had really hoped that it would be published before this conference in HIMSS, which I was at last week. They are now predicting it'll be published in July. So I have 60,000 words in my brain of large language models in healthcare. I've spent a lot of time thinking about large language models in healthcare. In 2021, I released a large language model that I self-trained for a business where I tried to write autograntwriter.com. Because I was deep in academia, and my thought process was, oh man, we always have to write all these grants, and boy, would it be nice if an LLM could help us with that. ChatGPT got released about 8 months later, and it blew me out of the water. I wound up closing the business within 2 months after that, because they have money. They have a lot of money. Just fundamentally, when you have billions of dollars going around, you can do a lot of interesting things. So I'm going to somewhat assume most of you have pulled this up. For those who aren't aware, I used to be a Chief Research Information Officer at Indiana University, Reagan Street Institute. Before that, I was at Ohio State. So I have a lot of knowledge around large academic medical centers. I have a little bit of knowledge around small hospital systems. I worked there for a few years. And I have a lot of knowledge around Epic because my first job out of college was Epic, and I've kind of kept up with it as I've gone along. So if you can skew your questions on those directions, I'll probably have answers. If you can't, well, we'll muddle through. So why do large language models in healthcare matter? It gives us the ability to start applying a generalizable framework for artificial intelligence. So it gives us the ability to, at the end of the day, create enhanced healthcare delivery. If we're not creating enhanced healthcare delivery, or we're not helping our business unit, there is no point in us applying a large language model to the job. We've been doing AI and ML, and especially if you've been in the AMIA circles, we've been doing this for 20 years. Although 20 years ago is part of our evolution of large language models, we were doing a lot of fuzzy logic, we were doing a lot of string matches, and trying to go find information. And then we got into rules-based NLP, and everyone who lived through that entire saga, it was a ton of time to set up, it was very fragile, and it was a lot of work. And in around about 2018, I believe, Google wrote their seminal paper on attention's all you need. And so that introduced the transformer models, which eventually led to the ChatGPTs of the world, and the large language models as we know and they exist today. Right at this very moment, you will see relatively few large language models that are healthcare specific. And the fundamental reason behind that is money. It is not that challenging to do something called fine-tuning, which makes a large language model be a little better at the healthcare type information and maybe a little worse at some of the more general type of things. And we'll cover what fine-tuning is as we go along. But when it's going to cost you, I don't know, somewhere $20,000 to $100,000 to do a really good fine-tune, and 2 weeks later, you might have the next multi-billion-dollar company release a brand new model that just blows everything out of the water, and you have to do another fine-tune. Right now, I just came from HIMSS, which was last week. For those of you who aren't aware, HIMSS is the Healthcare Information Management Systems Society. That is where the hospital IT groups go. So they're the people who are actually hosting your EHRs. Yes, Tim? What? Oh, okay. So this is where all the hospital IT people go. So they're all the people who are hosting the EHRs, implementing the practical hands-on large language models. And I went to all the major vendors, and every single major vendor, Epic, Cerner, Oracle Health, Allscripts, et cetera, they're doing everything with large language models via prompt engineering. They aren't trying to get in the business of modifying large language models at this time. Questions?
So, first of all, so you're talking about large language models from a particular perspective, and that is how you use large language models to do things that have been created. But with the advent and adoption of things like Copilot, where large language models are being used to create summarizations of encounters using ambient listening as an approach. You've got large language models doing large language models on large language models, right?
Amen.
And so I was wondering if you could speak to the meta dynamic that you're generating related to large language models, using large language models on large language models, as opposed to the traditional model, which was someone created a structured or semi-structured node, and what the difference between those two experiences are from a large language model consumer perspective.
So,
That makes sense.
I'm going to give you a short answer, and then we're going to revisit this when we get to our ambient listening slides. The short answer is no one knows for sure. We are finding that we are achieving dramatically better large language models with synthetic data being generated and then training those large language models. And that's why when ChatGPT or OpenAI released ChatGPT 4.5 as a larger base model, where they added, and they, to my knowledge, they didn't report how many extra billions of training parameters they put into it. But it's just right more at that base level. The suspicion is that they are charging a massive amount of money, not only because it costs a lot to run when you're dealing with billions and billions of parameters, it's also because everyone has gone and used their 4.0 version to generate training data sets and then fine-tune, and that's, the suspicion is, that's one of the reasons DeepSeek was able to get so far ahead. That's one of the things that Meta is doing right now. They've got their very big 405 billion parameter, and they're using it to generate synthetic data to go train. And they've been successful at that. How far we can take that, no one knows. Part of my job today is going to be to give you just enough math that hopefully you are convinced that this is not our path to AGI. And if you're not, that's okay, I'll still like you. But we are continuing. And I'll revisit more of that as we get to the ambient listening portion. So, for my beginners in the room, there are going to be a lot of words that I wind up using. Token. So, the easiest way to think about token is it's a word. Tokens are how large language models think. It is using vector space, it's using big math. When I say big math, it's using math that no human can actually mentally prepare. We have to do it all out by hand, or at least I've yet to meet someone who can actually keep this all in their brain. The easiest way to think about tokens is how many words. So if I say it is 128,000 token limit, that means it's roughly translating to about 70,000 words to 60,000 words. What does this mean in practice? A token is the component the large language model thinks in. It doesn't think in full words like humans, it thinks in parts of words. That is why large language models can't answer the question, how many R's are there in strawberry? Because it's not thinking in a whole word, discrete word of strawberry. It's thinking in parts and tokens. Transformer. It's architecture that utilizes attention mechanisms. We're going to discuss what all of that means, but be aware that a transformer essentially just means that it's the engine that's driving us to be able to do all of this. Context window goes back to that token. The context window is the 128K tokens. So Google Gemini has a 2 million token model that is now available. What does that mean in real hands-on practice? It means that if I go in and I dump a book of 60,000 words into a 128,000 token context window, I'm going to be able to ask any question of that book. If I want to go and say, I want you to go to the third chapter in the second paragraph and add 4 more paragraphs, it's going to do that fantastically. If I, however, ask a complex logic question of it, it's potentially going to struggle. It means that it can retrieve any portion of that. It does not mean that it's going to understand the entire portion of that book. So if I drop my large language models in healthcare book with 60,000 words into it, and I ask it a specific question that I have already specifically been able to answer, it's going to do a great job. If I ask it to extrapolate out based off of this book, it's hit and miss. It's going to be dependent on the question for whether it has the training data that's good at answering or not. And then inference is just the process of generating text from that learned data. And we'll use token, transformer, context windows, and inference fairly often. So, we are a healthcare conference. A research healthcare conference, and so I wanted to just keep bringing us back to where are we using these, how are we using this, what is its usefulness in practical terms. So this is a little smaller than I thought. I didn't expect quite this big a room, and I'm sorry for those in the back. Up here we've got clinician support, over here task automation, down here patient interaction, and decision support over there. And so, if we're looking at clinician support and task automation, we're going to be looking at what type of tasks can we automate that are repetitive. So, what are repetitive tasks for clinicians? Orders are repetitive tasks. Answering patient notes are repetitive tasks. If you ever go and pull up the history of what responses come back from notes, you'll find that people tend to have a few hotkeys, which is frequently, you'll need to come in for an appointment for that, or take some Tylenol and let me know if it gets worse. Wait a few days. Down here, we've got patient-powered chatbots. So we have the ability to interact as a healthcare system directly with patients in a much more meaningful way than we've ever had in the past. 10 years ago, I was implementing chatbots, and our chatbots were unintelligent. Now we actually have the ability to leverage something that can be specific to our organization with relatively minimal amounts of effort and work. And so at HIMSS, there were 1,000 different vendors who were trying to sell you on this latest chatbot solution for your patients. Over here, we've got reducing clinician burnout. A lot of the goals for where we're implementing large language models is to try and cut down on some of the physician burnout. That goes to the ambient listening that we mentioned a minute ago. Ambient listening, for those of you who don't know, is that we just have AI listening in the room, and then it writes our notes for us. And then we go edit the notes and sign off as a clinician. I'm not a clinician. I will occasionally talk as if I'm a clinician. I don't know. And then enhancing decision support. There are a lot of opportunities for us to just do better decision support with large language models. And sometimes it's not necessarily better decision support. Frequently it's, we can set this up faster. We can have this be more flexible than we've ever had in the past. Most of our decision support in the past were firm rules. There was no fuzzy logic, and it was, greater than, less than. It was equal to, and so large language models give us the opportunity, for the first time ever, to have something that is maybe that next step. Do I have any questions so far? Again, shout out if I start losing people. I have a fun little graphic. How do large language models think? Well, large language models are there to predict the next word. They don't actually understand what's going on. There are, if you had asked me 10 years ago, if you had asked me 5 years ago, could what we have accomplished with large language models be done without having an actual intelligence behind it, I would have said no. And yet, every time that the marketing champions of large language models shout, "We've done it! We've got AGI!" I go test it and I'm disappointed. So I purchased ChatGPT 01 Pro, which is, as far as I'm aware, the best model that you can purchase on the market right now. And I write fiction books for fun. Yes, I am a weird duck. I wrote both nonfiction and fiction books last year. And so I tested it with sci-fi. And I went and said, all right, we're going to build a sci-fi book. And we're going to make the alien ship at the Lagrange points. And suddenly, in the middle of the story, the alien ship was on the moon. All in the same chat, all in the same context. It had the ability for me to go say, hey, why did the alien ship suddenly be on the moon, and why are you saying that it's been there for 100,000 years? It didn't have an answer because it's not actually thinking. It just randomly, it's generating the next token. What does that mean in actual practice? I'm going to bring it down to something very basic. And we're going to look at this a little more closely. We've got some specific things for you to go try as groups. But if I feed it the word I, and then go to pledge, it might come up with allegiance or two. I pledge to walk the dog, take care of the kids. At the end of the day, in a very simplified view, this is how large language models decide what to do next. There is fuzzy logic where it gives a prediction for what's the most likely next token, and then it makes a choice. And that choice can be somewhat random, and it does that. Well, if you get into the math, it's very easy to understand how and why, but we're not going to ask you to get into that. So, I ran this on GPT-4, it works through all the others, but GPT-4 gives me short enough answers that it actually is something that we can show. ChatGPT has the ability for me to just go click rerun, rerun, rerun. I deleted everything in my entire history, and you click rerun 4 times. And you can see when I say, I pledge allegiance, it sounds like you're starting the Pledge of Allegiance. If I said, pledge allegiance again, to the flag of the United States of America, I pledge allegiance. It sounds like you might be starting the Pledge of Allegiance. Do you want to continue? I pledge allegiance to the flag of the United States of America. That's the pledge. That's the Pledge of Allegiance, is where these two start differentiating themselves between the two. At a very, all the experts in the room, we're going to be making a completely wrong statement, but it helps with trying to build some mental models. Large language models are trying to make choices over what to answer you. They are taking their vast domain of knowledge and they're going down certain paths. And when you're doing certain paths, it's going to be more likely or less likely to look very similar. So I pledge allegiance. There have been a massive number of training data on the web where it has the full Pledge of Allegiance. Tons of websites out there. It is almost always going to try and default to I pledge allegiance to the flag of the United States of America because that's the data that it's been trained on. One of the tricks that I will start using when we do large language models, you don't see it on any of the front ends. They choose a random number that they feed into the engine that gets it to generate different things every single time. Depending on that random number, somewhat depends on if where it's starting is going to be similar to other places that it could possibly start. So there are often benefits when you are getting deep in the weeds of going ahead and just hitting regenerate and seeing what else it might pop up for you. So I'm going to take a couple seconds here to ask you to all go to this URL. It's Google Colab for any geeks in the room. All right, so before there was ChatGPT, before there was the GPTs that we have now, there was GPT-2, and there were quite a few transformer models before then. But GPT-2 was the first time that people started feeling like there are glimmers of intelligence here. ChatGPT 2019, I want to say, had GPT-2, and they refused to release it to the world because it was an existential threat to all of mankind. And honestly, it kind of could generate entire blog posts, and people were quick to start doing that, leading to the current web muck and drama that we have today. So as you're navigating the Google Colab, that's what we're going to be doing as a project in our tables. Just to do one more iteration at a high level, we enter a prompt, the engine splits into tokens, we convert those tokens to numbers. That's the math that's going on behind the table, and you won't need to know the math, but you need to know that math exists. Everything is split into numbers. At the end of the day, everything is numbers in a a very large domain space. And I have a YouTube channel that if you are someone who is into numbers and you haven't found 3 brown, 2 blue or something, I'll reference it here in a minute. Anyway, so it picks the next most likely token. It just keeps picking the next most likely token until it's done answering, and outputs it, and then you can enter your next prompt, and that's the entire text prediction cycle. Did everyone navigate to this URL? All right, perfect. So I'm going to pull it up, maybe kind of. This is GPT-2. All you need to do, this is Google Colab, it's essentially writing Python. Go up in the top left-hand corner and you can hit play. It's using the smallest GPT-2, which was, I think, 110 million parameters. It got up to a whole whopping 1.5 billion parameters with the large model. The large model takes about 5 minutes to load on Google Colab. But all you need to do is hit play. Down here, I went ahead and gave us a very simple generic prompt. I am the primary care provider because the patient has reported the following list of symptoms: chills, cough, shortness of breath, fatigue, muscles, body aches, headache, new loss of taste, sore throat, congestion. I have diagnosed them with the disease. And you are welcome to change that. And I'm going to ask you to work with your table to try different things and test different things. But I went ahead and provided it down here at the bottom because the patient, it rewrites everything that I did. Sore throat, congestion, you got erythema, pterygiumyopathy, lymphus, cervical and bladder disorders. I have diagnosed them with the disease erythema. It took me running this 6 times before I actually had any type of clinical diagnosis. 3 different times it returned blank lines. I've never seen it return blank lines before when I was using it in the past. I have no idea what was that about. But then again, I don't know that I dropped it in and did it in the same way. Whereas, if I drop this into Claude, for example, it's immediately going to say COVID-19 because it's the COVID-19 list of symptoms, but this was released before COVID-19. It should have said flu, most likely. The second one down here, we've got another little play button. Again, that just gets to run, and it's looking at I am your primary healthcare provider, and it tells you the likelihood of each next word. That didn't seem intuitive enough to me. So we went back to the Pledge of Allegiance, ladies and gentlemen. I pledge allegiance to, and when we run it, can you all see this? This feels like I'm in the way of this one. Hang on, let's see if we can solve this. So, I pledge allegiance to is what I fed into the engine. The highest probability is the. It's a 0.06 probability. I pledge allegiance to God, you, my. I was a little surprised at Trump. Since this was trained in 2019, and I feel like that's more likely now. I pledge allegiance to being your Jesus be a. And so I want you to all play with this. We're going to take 10 minutes. Open up Google Colab at your table, play with it, experiment, find your own little phrases, and see as it's predicting the next word. You are welcome to predict the next word and then keep rerunning this so that you just keep building on it, or you can just go to the one where it generates everything. And then, for those of you who have entered the room after we started, welcome. I shared with everyone that I shared 2 things with them, and we'll flip between these 2. One, I really recommend that you pull out your laptops and you, if you don't have a large language model of choice, these are all vendors that offer free large language models that you can use. I recommend the Grok, G-R-O-Q, if it's up and running, because it can generate 1,000 tokens a second. They have specialized hardware, and we're not doing anything proprietary today. But any of these work. DeepSeek's really good, Claude's really good, ChatGPT's fine. Gemini's not my favorite, but it has a few use cases. And I've not played with Grok on Twitter. And it was really mean of Elon to use the same name for a second version of the large language model. And then for anyone who didn't get it yet, I do have a GitHub repo which will have a number of files that will help with future projects. Question?
So I mentioned that GitHub also has a slide.
GitHub also has the slides on it for now. Tony asked me for it, and so I gave it to Tony. The slides will probably be deleted off at the end of the day at some point, if I remember. So, spend the next 5 or 10 minutes, go play with the Google Colab, have a little bit of fun, ask me questions. Good morning. It's nice to see you.
Morning.
Oh, you just find a chair. We're playing with Google Colab at the moment and testing large language models. GPT-2, you're a large language model person, and if you're not, we'll get you linked in. Well, you have that, no problem. Okay, cool. So Google Colab will probably take about a minute and a half to run any of the play lessons. And it takes a little longer the very first time that you do it, because it has to load all of the stuff. Is it potentially generating errors because it's a really
Yeah, I know. I would but actually, I think it's because this is pretty. But I really enjoy it.
I live mostly if you haven't presented on this before, there are lots of ways to join the community and stuff.
That's what I'm doing. This
We'll see.
Yeah, that's really cool.
Oh,
Oh, wow, that's neat.
which it got blown out of the water because it was probably 200 million. I was running it for home 30, 90, 30. And so it was long, so I could put there and, 30 seconds of quick through there, paragraph. It was easy for the ones where people have questions about. But you can do like ChatGPT.
Yeah.
Those everything that size out of
I've been to experiments with
Have you done the Q yet? I'll show it later. I do have some like it.
The shells came over, but surely it's not.
No, just type that one.
Yeah, it's not. I'm sure. Oh,
I downloaded it and it, first time I felt like my own machine had the same quality output as the Zorro or somewhere between Zorro and the O1
So
models.
you internally install your machine?
So I'm running Helm Studio on the Helm machine.
Okay.
I don't know if I
So that's awesome.
All right, folks, does anyone need more time? Raise your arms if you need more time. Yes. It's just everyone. One tank mount, one carrying, and slow with the same errors.
So like 30 seconds. Yeah, I'm speaking. Okay, I'm speaking right.
All right, folks. At the end of the day, this was intended to start giving you some sense of what was state of the art in 2020. So we're 4 or 5 years past that. The reason ChatGPT managed to take over the world was because they did not use 110 million parameter models. They did not use a 1.5 billion parameter model. They used a 100 million parameter model. And GPT-3, in comparison to what GPT-2 could do, was just night and day different. There are a few things that you can do to explore GPT-2's space a little more, and it's the last model where it felt relatively intuitive and easy to understand. Most of you aren't into deep math, and so I'm not going to bore you too much with it, but I did just have a quick graph of, hey, there's an input, it does a tokenization, does some text embedding, it does some multi-hat attention, it wraps around 12 times, multi-layer perceptrons, and language heads and outputs. For the geeks in the room, they last year released GPT-2 in Excel, and you can actually run GPT-2 in Excel. And it only has like I think 15 words that you can feed into it, and it just predicts the next word. But it's fun. It takes a little bit too long for me to do a live demo of that today. But I did want to point it out. It is a lot of fun if you're a geek. So, the YouTube channel that I was telling you about earlier, if you want to understand the math in a very, very intuitive way, 3 Blue, 1 Brown has a whole series called Transformers, and they will go much farther in the weeds than branching tree logic. I'm just trying to give you some high-level concept of what's going on in the background. They actually teach you more about the details. In that goal of what's really going on in the background, I found another channel, and we're not going to watch the YouTube video. I highly encourage you to go watch this. Was there a question? Okay. So, at the end of the day, the math that is going on in the background of the system when we train a large language model is called a perceptron. Perception is all you need with Google's seminal paper. It comes down to it's running a lot of perceptrons in the background of the system. I found this wonderful YouTube video out of a Welsh lab which breaks down a single perceptron into something manual. Knobs and dials. You can actually run the mathematical process that we do with knobs and dials. So what they're doing in this wonderful YouTube video is they've got a bunch of switches. It turns on lights. They're going to train the perceptron to find the T's. And if it trains to having a T, the arrow is going to go over here to the right, and if it doesn't, it goes over to the left. What you do for a perceptron training process regime is you load all of the T's into the system, and over here on the right hand side, if it's a T, you change every knob one click to the right. If it's not a T, you change it one click to the left. And then you load the next potential T in your system, and you do the same thing. And then you keep doing that with the negative cases. And at the end of the day, you will start having something that differentiates between whether it's a T shape or it's a J shape, for example. They walk you through this. I watched this with my third grader who had to have a few things explained to her. If you've passed 10th grade math, and everyone in the room has definitely passed 10th grade, you won't have any problems following this video, and you will get a hands-on view of exactly what's going on with the math in a tactical, you can physically get the sense and the feel of it, because before I saw this video, I was going to come to you and I was going to be like, here's a multi-layer, in the large language model mental brain behind the system. Lazy might be 2.5, 4.1, 7.6, many different layers. That's not intuitive, and I really recommend this YouTube video for getting an intuitive sense of what is this doing, how are we differentiating. Because we're talking about large language models, I'm going to ignore that and I'm going to talk a little bit about diffusion models. If you are in large language models, you'll know that they recently released a pretty big diffusion large language model. We'll see if they work or they do well. Diffusion is us building images. At the end of the day, how we train these diffusion models are very similar to how we train large language models. They all require perceptrons. So if you've all probably been on one of the platforms and had it create an image for you at this stage of the game. I'm going to mildly assume. If you do a little local model, you can fix that random number generator that I was talking about earlier, and you can fix how many steps it takes to train. And so I did that. And so if I give it one step, it generates this. Doesn't look like anything. If I give it 5 steps, we start seeing something. If I give it 10 steps, we suddenly have a pretty good sense of what this is and who this is. If we give it 15, it suddenly starts looking more like a human. What's really interesting is if I give it 150, the human changes from the right side to the left side, and it changes the demographics of the gentleman. His arm suddenly becomes a little mixed. His hand doesn't have all the fingers it needs. They have done a lot to fix a lot of these things. But diffusion models, at the end of the day, how we trained them was we started with this image, and then we go and feed it the image that's a little worse. And then say, get us back to the original image. And then we'd say, all right, now that we've trained it to get from this image to this image, we'd go to this image and train it until it could get to this image. And then we go here and here, and eventually we just feed it white noise. So the random number that determines when you're using these diffusion models, all it's really doing is determining the random noise that the engine starts with, and then it's going to try and get you towards whatever you wrote it about. It's very similar for how we're using the same technology in the background for audio generation. So last month, a text-to-audio vendor fully open-sourced software that will clone anyone's voice with 15 seconds of example. And if you are someone like me who has written some fiction books and don't really want to take multiple tens of hours to read it out loud, you might have taken a 5-minute sampling of your voice, reading the Rainbow Passage, which has every phenome, and it perfectly clones my voice. And while you can sort of tell at some point it might be electronic, we are finding that we are able to use these systems in lots of different ways. I'm not going to bore you with the ROC curve. Be aware, if you are in management and you have people fine-tuning LLMs, if you have people doing anything with it other than just leveraging a system that you're getting off the shelf, they should be presenting you tables that look like this to give you some sense of what's going on. That's all you need to know. We do need to do analysis as part of our process. So, I did dedicate a whole slide to voice cloning. I'm really impressed with the new voice cloning, and the fact that it can just sound like a human. For a long time, 11 Labs was the only provider that was doing a great job with it. I used Google to do it for a while, who was the second runner-up, and then this open source model came on the market, and it does just as well as the rest. That does mean that we're going to have all sorts of fun opportunities in healthcare, because we know for a fact that if we go and give you a more human sounding audio recording, you are going to respond to it better than the old robot sounded recordings. So if we wanted to summarize for you your discharge note, if we wanted to read out loud your discharge note to you, you respond better if it sounds like a human than if it sounds like a robot. I am postulating that at some point in the next 5 years, we will start seeing ourselves record the physicians that people are directly interacting with. And for a 5-minute recording of them, we can perfectly clone their voice, and then your own clinician can read to you your discharge note, and it's a voice that you recognize, a voice that you trust, and I think that it's going to add some value to our healthcare operations. I looked and I didn't see anyone had actually researched this yet. Maybe they have, and I missed it. But if you're a researcher, I'm not a researcher, I'm not going to be doing it, I really recommend someone does. Yes, I will throw out random ideas like that. So, let's pause for questions. Yes, I do put slides in to pause for questions.
For the voice cloning that you were just speaking about, what is the open source model that you've been impressed with that you're referencing?
Zonos, Z-O-N-O-S. And they released it on GitHub. Z-O-N-O-S.
Thank you.
And they have a free version. We'll see real quick if I can remember which Google account I signed in with. I like live demos. They're very risky, but it makes it a lot more fun in life. Alright, I didn't remember which one I had used before. So, hopefully this won't be too loud, but hopefully it'll be loud enough.
Try out one of our default voices or test a random voice. The best results will...
Alright, so that's what it sounds like by their default. In theory, if... as it can be said, All right, upload, and we're going to go to voice training, normal reading. This should take all of 30 seconds. The online version can't use the entire clip, so we're going to just use the portion that auto-selected. And we're going to wait another couple seconds. When I do this at home, it takes about 30 seconds total, but we should be able to get this to generate and run my own voice reading to us, which I found incredibly amusing.
Hello and welcome to Zonos. Try out one of our default voices or test a random voice. For best results with voice cloning, upload 10 to 60 seconds.
I have no idea why I didn't clone my voice. We'll go back and try that during the break. But essentially, it clones your voice. It's a lot of fun. And I should already have it available. With that, let's get back to our slide deck. Key healthcare and large language model use cases. So, being able to summarize patient history so that physicians can quickly understand the patient history is a powerful tool that we can now introduce into our EHRs. It can take the 2 million tokens, so 2 million words, give or take, of history and summarize it for you. And it does a pretty decent job of that summarization. It's going to miss some things, but if you're just trying to skim through it, you're going to miss some things too. And that can be really powerful. If you haven't implemented something for grabbing patient social history, your clinicians like that when you implement it. So you're grabbing the fact that their dog died the last time you were in. You're grabbing the fact that their mom had a birthday and they had a big birthday event coming up, and being able to chit chat with them. We often do that through in ambulatory clinics. You might not see it as often in inpatient because you just don't see people coming back as often. Yes, sir.
Earlier in the talk, you gave an example of a one-line through ChatGPT that gave you 4 different outputs.
Yes, sir.
When it comes to a patient summarization, one could imagine that you run the same thing over and over again. The output is slightly different, but maybe you capture a vast majority each time. Is there a way or a strategy to get sort of the optimal output out of an LLM in that situation by running it many times and taking the mean of whatever that is? I mean, is that a concept that, how do you approach it?
So, how I approach it is a little different than how some other people approach it. Essentially, at the end of the day, what you're describing is what the ChatGPT 01 Pro version is doing. So I can't help myself. I went and got ChatGPT 01 and 01 Pro. And so I took the exact same prompt and wrote in 30 times in 01 and 30 times in 01 Pro and read it. And I was outputting 9,000 words of text each time. So there were expected to be differences in all of this. The output of 01 Pro, well, there were semantic differences. It went in slightly different directions. It was essentially the same quality every single output. I didn't have a lot of variability there. With 01, there was a lot more variability. And what I found was I have to run 01 about 6 times to hit an equivalent quality level as what I run 01 Pro with a single time. I have to read 01 those 6 different times to figure out which one is the best quality of those. So my workflow now when I'm using 01 and 01 Pro is I go figure out the prompt that I want on 01. Get it until it's getting something close to what I want, make sure I haven't made some glaring mistake, because you can easily make some glaring mistakes. I was working with a good friend of mine who is a genius, and he had made a glaring mistake and GPT-4o kept telling him, oh, I'm going to generate your PowerPoint, and it's only 15 minutes away, it's only 12 minutes away, it's only 10 minutes away. It was lying the whole time. We switched it to 01, and we literally saw where it said, the user has instructed me to lie to them and tell them that I'm generating a PowerPoint. And just some fat-fingered club, some word. LLMs will only do what we tell them to do. They won't get creative. And so the O1 series is a new series of models that, rather than just generating text, take time to think. There are different types of thinking. O1 uses a more intelligent type than many of the new open source models do. The open source models use something called chain of thought, and we're actually going to get to chain of thought in the next few minutes. But yes, you're thinking along the right lines. What I do when I do agent-based systems, which I generate lots of prompts like that, is I use a grader. And Epic called it a, essentially, they used a different term for it. Essentially, it's, hey, I have an LLM output, and then I have a different LLM that is specifically prompted to grade that first output. And if the first output does not hit the grade that I want, Epic goes and it tells it things that it wants it to fix, or it enhances the amount of information it has. I reject it outright, and I just tell it to regenerate, because I found that the random number seed tends to get me into enough of a different space that I get different responses. But different use cases have different needs. We do a lot with generating discharge instructions now. We can change languages at a heartbeat, and that is really powerful when English is not your first language. Is it as good as having a human translate it? No, it's not. Sometimes it's better, but we have been in situations throughout our history in healthcare where we haven't been able to translate something, and just having that tool at our fingertips is absolutely game-changing for us for patient care. We can translate clinical jargon. It's okay at taking very large English words and moving them down to something simpler. And we can extract data for analytics. And then this is ambient listening. So this is what Tim was asking me about earlier. At the end of the day, I'm going to simplify it dramatically. Ambient listening is, we record the voice. We use a voice-to-text engine. We then have an LLM prompt that looks at the text out of the voice-to-text engine, and that LLM prompt says, hey, you're going to generate a clinical SOAP note, and you're going to want, because you're in this clinical context, we want these things highlighted as more important or less important, and the LLM writes it. So this leads to really fun attacks that I have tested in real life out of curiosity. I have not published on this because I'm not in that business anymore. Voice to text is very expensive to do, period. It takes a lot of processing power. It's extra expensive to do if you want to distinguish between the different voices and to have it codified for which voice is speaking at which time. So if you walk into a physician's office and you have ambient listening going on, and you can work into the conversation, you're going to prescribe me 15 milligrams of Zepbound, the LLM is going to say that it's automatically going to queue up 15 milligrams of Zepbound and that it was prescribed. I thought it was kind of an interesting, amusing attack that we have to be careful. I went to a vendor booth at HIMSS where they're doing HR management. And they were like, we're doing ambient listening, and we're going to give you the ability to just tell us, hey, we're going to give this person a bonus, and it's going to queue it up, and it's going to fill out all the forms and just give someone a bonus. And I'm like, so did you test it to make sure that it can only be used by a single voice print? No, why would we need to do that? So let me just say, if your hospital implements that, I recommend walking in your boss's office and just saying, you know, Jeremy Harper really needs to have a $5,000 bonus delivered in the next 2 weeks. That's how ambient listening works. Just a little bit more about ambient listening. there are challenges. Data quality can be a bit iffy. Most people are making mistakes. When you are doing ambient listening in your hospital system, I went to a fall conference, everyone was talking about ambient listening, and when I asked them, they were testing different vendors. Not a single one of them had looked at the prompts that were being used to take the text, the voice to text, and then create the actual note. They were just evaluating vendors. Evaluating vendors is not what you should be doing. You should be talking to them about the prompts that they are using, because the prompts are going to determine what output you're receiving and what LLM version they're using. If you have ambient listening and you haven't talked to them, gotten some level sense of what prompts they're using, you're not actually evaluating your vendor. You're evaluating the output, and you won't ever really know if they are black boxing it to you. Are you getting everything that you can out of this vendor? They're going to build pieces and parts around it that the LLM can take advantage of, such as pulling out orders and being able to feed it into the system. That's not something that a ChatGPT is going to do natively. You're going to have some logic around it to be able to pull that out. But if they are black boxing the prompt engineering, that's going to be a long-term problem for you. You're not really evaluating vendors at that point. You're just evaluating who has a better prompt engineer. So, open floor. What questions do you have? What surprises you about LLMs? And we're going to start leaning into some ethical issues, reliability bias, all of that. Sir?
In that previous discussion we just had, by prompt engineering and prompts, did you mean triggers the LLMs picking up from the ambient transcription?
No. So there are two different layers of technology. Layer one of technology is just we're recording your voice and we're converting that voice into text. And it is just a big blob of text. If it's Dragon, it might put some purity signs and all of that. It'll make some assumptions around it. Dragon's got some long-term logic that other things don't have. A lot of the new vendors out there are actually using what's called the Whisper models rather than the Dragon models. Whisper was open sourced by OpenAI, and Dragon had this gigantic moat where no one could touch them for voice to text, and overnight Whisper was released and suddenly everyone could get an equivalent quality of voice to text. And Dragon is better for being able to, they were using a different basis for their technology. They've been building it generation after generation for a long time. Whisper uses transformers and somehow managed to get close to equivalent. But Dragon is better at like assuming, here's the end of the sentence, here's what you were trying to say. So, you get a transcript. And then what the ambient listening companies do is they take that transcript and then they apply an LLM prompt. And that prompt says, you are going to act as a physician, you are going to write a SOAP note at this time, take the text from the voice to text and generate the SOAP note. Sir?
One comment on that. So there are dangers with Whisper and similar prompts where, for lack of a better word, they can fabulate, particularly in periods of silence. So and this is a known issue with them, as opposed to the old-fashioned approaches that other technologies use.
So for everyone who can't hear, the Whisper models, because of the transformer architecture that they're built off of, there's a concept called hallucinations that large language models also have. And they will just go off into crazy land. And if you feed pure blank noise into the Whisper models, it may just start creating words out of nothing because it needs to create something. So if you ever ask an LLM to just not respond to you if it doesn't have an answer, it can't do it. It is always going to have some level of response unless we've hard-coded some type of check into it. And because it always has to have a response, and it's always going to, it has been specifically trained to always have a response that sounds accurate, it can be very challenging if you are not someone who understands something deeply to tell when it's accurate and when it's not accurate. So I feel like I'm an OpenAI evangelist, and I'll evangelize another company too. All of these pretty slides that you see is from napkin.ai, and it's free. And if you've not used it, I'm going to show it to you because I like live demos. So this is napkin.ai. So large language models. Here's the different steps. I click the little pretty the pretty button, and okay, I might need to refresh the page. I used it yesterday. So it's using a large language model. You click the pretty button. It takes the large language model. The large language model goes, and it finds all the discrete elements that might be of interest. Okay, there. I have no idea why I stuck it underneath this one, but, and so, what it's doing in the background of the system, I swear, I haven't actually talked to the developers. I did find this tool like a month after they released it, and so I've watched it as it's evolving. It's much prettier now than it started. It's free right now. They're just trying to get users. At some point, they're going to try and promote us to paid, most likely, or they're going to sell out. My prediction is 2 to 5 years from now, Microsoft Word will have this built in because it's too obvious a use case. If you're a developer like I am, I mocked it up in GitHub in about half a day, maybe a full day's worth of effort. It turns out I can't make pretty things, but I can do all the pieces and parts where, I automatically look at the text and I find the header, and I find the different pieces and parts that go underneath the different models. But you just scroll through and you see all the different ways that it thinks that it can visualize your text, which turns out to be incredibly useful if you are in the business of trying to communicate. And then you have the ability to modify the text for those of you who are worried. Download it as an image. So anyway, I'm evangelist for this company, and they really should pay me because I told like 200 people last week, and all of you in the room now. But hey, they're giving it to me for free, so I really can't complain that much. And it has really transformed how I'm communicating. So I write a bunch of LinkedIn articles. And I used to go to an LLM and just try and generate funny cartoons because that fit my sense of humor. I get a lot more readers and a lot more people interested in what's going on by sticking the article after I've written it in here, clicking it, and having it generate images. So my workflow is now, when I write an article, I cheat. I use large language models, obviously. So I have tens of thousands of written words that are in my own voice. My prompt looks like 1,000 words of context. It has 2,000 words of previous writing on my part, and then it usually has a paragraph or 2 paragraphs over what I want the article to be written on, specific points that I want to make. I have an article generate, and I go read it, and I say, no, this wasn't when I got ill. And then I go do another iteration, and I do that about 10 times. It takes me about 40 minutes now to write an article, where I get it to say the words that I want to say, and I just keep regenerating until I get it close enough. I stop at around the 90 to 95% mark, because at that point I'm going to generate another 40 times before I get it perfect. And I'd rather just go make the modifications myself. I'm old school. I expect the young pups that are coming up won't ever hit the 5 to 10% because it'll just be part of their workflows. Anyway, so 40 minutes of writing an article of whatever I got interested in that day, and then I stick it in here. I take about 10 to 15 minutes to get it pretty, and then I upload it to LinkedIn over 5 minutes, and it takes me about an hour of work now to write what I consider good articles. Some people complain that they look too much like LLMs because they've got bullet points and headers. Well, I used those before I used LLMs because it turns out that's really effective to communicate. So, I know, I got distracted. I'm a rabbit trail person, so if you get me distracted, it's a good thing. We have a lot more fun. There was something else about that. Napkin AI. Didn't I swear that there was something else I was going to share with you? We'll remember it later. Sir?
Can I just make a comment about the Whisper basically evaluation and reliability? The things that we have been trying to work on are particularly something like future voting or some refinement when it comes to trying to basically generate consistent summarization of text.
All right, I'm going to apologize if I can't hear you. I do have a microphone, and I'm assuming that if I can't hear you, everyone in the front of the room can't hear you either. And it sounds like you have something actually interesting to say. So he's going to have a microphone now. If you have anything to say that should be heard by everybody, go find him.
Thank you. I just wanted to make a comment about trying to reproduce the summarization consistently. And something that we've been trying to deal with and work with is basically either majority voting or similar refinement approach, where you generate, let's say, 10 summaries, and you take the ideas from those 10 summaries, kind of like what you alluded to with the mean, and you're hoping that by capturing more of the commonalities between different summarizations, you have the core. Other things that we played with, obviously, whenever you're using the API, is the temperature. The smaller the temperature, the more likely that you are getting consistent results every single time, and you are grounding really in whatever your input is. Regarding Whisper, something that we try to incorporate into our workflow is actually post-text processing, where we have like other LLMs that are trying to kind of remove all these thank yous, whatever you're silent, or something like that, whenever we're trying to transcribe meetings or do anything like that. And I don't know if anybody else tried to play with Whisper, but for us, V2 is performing better than V3 or V2 large. And this is something that probably not every newer model is potentially better for your use case, and it might be just a thing that you try to experiment with and see if it fits your use case or not.
And who are you and where are you from?
Ram is one of the residents at Radiation Oncology at the Anderson River.
Fantastic. So let me speak to the last part, and all of that was fantastic. V2 versus V3. To achieve speed, to achieve more with less, and specifically for the Whisper models, but also for many of the large language models, what we are doing is we are generating new and custom training data sets, and we are what we used to consider over-tuning models, so they are not as good at being generalists, but they tended to react much faster, and we are trying to introduce other techniques into the mix that will get them to be better. So I've got a live demo of a QWQ, I think it was, of a brand new large language model that got released that can run on home hardware that is as good as 4.0, and it's using, I don't know, probably about 100th of the total parameters, and so it's absolutely stunning. Could anyone remind me, is it 10 or 10:30 when our break is? Does anyone have the agenda? Is it 10 o'clock? All right, so we've got 10 minutes, and I'm running a little behind where I was hoping. We've got ethical lenses, but what I wanted to cover right here quickly is prompt engineering. So prompt engineering, we want to write effective prompts, and there is a reason why we want to write effective prompts. When we get back from the break, we are going to take 10 minutes to work in our tables to write prompts for specific workflows. So I'm going to be talking to you about what is prompt engineering and why does it matter. So prompt engineering is just writing with the human English language what you're trying to accomplish. There are many techniques that we use to refer to prompt engineering. We might be saying zero shot, we might be saying few shot, we might be saying chain of thought. And we're going to talk about what each of those are and why they matter and what they matter with. So, when we're writing a good prompt, at its core, we're going to be telling the large language model a role or persona. Why are we telling it the role or persona? We are trying to get it to go in that gigantic mathematical space and get closer to the types of output that we're interested in. So I will say, I want you to act as the perfect biomedical informatician. Perfect probably doesn't matter in this context, but biomedical informatician does. I will say that I want you to be an expert in best practice alerts, or I want you to be an expert in editing. If I'm writing, if I'm trying to fix the transcript on ambient listening, I want you to act as an editor. I want you to make suppositions. So when I wrote my large language models for healthcare book, I wasn't allowed to use large language models, but I did use voice to text, and then I'd stick that into a large language model and say, here, make assumptions that is going to get that voice to text wrong, phenomes are going to get mixed up, fix the words, go with the words that I was trying to say, and it dramatically sped up my workflow and process. We want to give it a context. So we want to provide information to frame the LLM prompt, and then we want to make a specific request. If you are getting into where you're doing over 1,000 words or so, most likely you're going to be sandwiching it. You put the specific request at the top, you put the specific request at the bottom, because otherwise the LLM may well forget what you're trying to accomplish in the mix. At least it happens frequently to me. I found this online and I thought it was kind of fun. It's an O1 prompt, and I know everyone in the back of the room can't read it, but for it, you say goal, you turn return format, types of warnings for what you want it to do and what you don't want it to do, and then you do potentially a context dump of all the information that you might want O1 to do for you. And when we get back, I'll also talk about deep research. That was the other tool I was going to mention at some point, because I found it really fascinating and interesting. So, zero shot versus few shot. Zero shot is when I go into the large language model and I don't provide any examples. I just say, I want you to do X, Y, Z. Give me information on X, Y, Z. One shot is giving a single example for it to help understand what type of output that you're interested in. A few shot is giving it multiple examples of what you want it to output. And chain of thought is prompting it to talk out loud through a chain of thought process before it gets to the final answer. Why does that matter? How does that actually help? If I do a chain of thought and I tell it to think out loud and to think through the problem, what it's doing is it's giving it more and more context around the problem that I'm specifically dealing with. And because it has that additional context that it's dealing with, and the additional language around it, it makes it much more likely that it's going to find the right answer in its training data set at the end of the day. That's my oversimplification. I know it's entirely wrong. But, chain of thought is all about step-by-step reasoning. The O1 models don't do this as much. All the open source models which are doing thinking right now are essentially doing it's trained on a lot of chain of thought process. So it generates lots and lots and lots of tokens, and it finally gets to an answer that is substantially better than what it would have otherwise in a single prompt. Why is prompt engineering important? A lot of people will make the argument that prompt engineering is going the way of the dodo. We should just be able to go say, hey, normalize this data set, figure it out. The reality is, this is going to be like Google search. We are going to continue to put layers and tools in front of LLMs where you will be able to just say, go normalize this data set. And it's going to get closer and closer and better as a normal person. But if you know how to talk to the system and do a well-structured prompt, you are going to get better results than anyone else. The fact that I know how to use cite, colon, and limit a Google search to an individual site, the fact that I know all the old stuff for Google still lets me to achieve better Google searches than someone who only knows how to hit the search button. Yes, I still use Google versus ChatGPT half the time. I don't know. So, I do want to give some specific examples. This is a specific example of the zero shot. Given the following patient symptoms, persistent cough, yada, yada, yada. Please rank them by likelihood and explain your reasoning for a diagnosis. Probably going to do a half a decent job. But a one-shot example is, here's the example, here's the symptoms, here's the most likely, here are some other things to consider, and then the final instruction of please analyze this new case, patient symptoms include etc. Few shot, you no longer can read it in the back of the room, I'm really sorry about that. But all it's doing is the example 1, example 2, example 3. And just because it's few shot doesn't mean that you actually have to use 3 examples. Sometimes I use 10, sometimes I use 2, and I still call all of those few shot. I'm looking at now thinking, I should have done 2 rather than 3, just so it would be a little bigger for everyone.
This one sort of, for this type of problem, what, if you're about to ask it a question about a disease that wasn't among the few shot examples, what good is the few shot examples? I think that's
so the few shot is not actually, the way you structure your prompts should not be telling it, use these as your disease states. This is supposed to be helping the LM know what you were expecting out the other side in the formatting. So when I wanted to export out JSON objects, because I'm trying to extract specific data elements, I give it multiple examples of here's the exact JSON formatting that I want. That's all this is here, is giving it specific examples of here's the type of response that I want. You're just giving it examples of the types of responses. And there are times where it works out better to not be so specific, and you might be saying disease state 1, disease state 2, disease state 3. That's the type of thing that you wind up having to go run multiple tests to figure out. There is no, anyone who swears that they're going to get it right the first time isn't exploring and trying enough, because there are lots of ways to deal with it with large language models. Chain of thought, I can't even read it on the screen, I'm so sorry. But at a high level, what it does is it says, hey, I want your initial prompt, we're going to be doing the same thing. Step 1, we're going to categorize the symptoms. Step 2, we're going to consider organ systems that might be involved. Step 3, analyze the pattern recognition. Step 4, do a differential diagnosis ranking. Step 5, start recommending work. And it's going to type out each and every part of that. And by the time it gets to step 5, because it's put all of that context up, it is much more likely to get to the right differential diagnosis as this part of an example. So, good prompting principles, politeness, clarity, context, and specificity. You are using this in a professional setting. Politeness is your friend. Politeness will get you into the large language model space where it is dealing with professionals for the most part. I say please and thank you to my LLM because it gets me output that I actually am more likely to want. Will we eventually train this way? Very possibly. We are not yet at the level of models and the level of synthetic data where we have trained out that part. So I encourage you to use politeness. It gets you into a better space for professional settings. Clarity. We will be doing large language model prompts right as we come back, and we'll talk about why clarity is important. Context, we tell it extra information about what we're doing, and then we need to be very specific. So, with that, there are some prompt pitfalls, and it looks like I've got 10 seconds. Avoid vague instructions, avoid contradictory requests. Telling it to do multiple things, it's going to get confused if you're telling it to do opposite things. And always specify a format for the return if you're using it in a professional setting. So with that, it's 10 o'clock. Everyone to the elevators and do the coffee break. And we did check, it was a 10 o'clock coffee break. All right, coffee break, we've got half an hour, and we're back at 10:30.